7th graders, it's time for another review of pre-algebra, and today we're going to review order of operations and substitution, and we'll kind of roll in our integer rules into this as well. So order of operations refers to the order in which all math problems must be completed in order to get the correct answer. It's no surprise that in math order should matter because the math is so structured, isn't it? There's a step-by-step process for everything, it seems. There's a step-by-step process in order to figure out how to solve problems as well, which is good. Otherwise, you could get several answers instead of one, and that could be quite frustrating. All right, so many of you memorized the PEMDAS, or please excuse my dear Aunt Sally. Just a little clarification. The P, yes, it means solve anything inside parentheses first. So when you see a problem, look for parentheses, and whatever's in there you're going to solve, but you have to solve it according to this. So we still have to follow the order of operations once we're inside the parentheses. After you've solved inside the parentheses, then we're looking for any exponents, and this year you're going to be applying square roots to that as well, and cubed roots sometimes. Roots just look like that. There are values inside. It's called a radical sign. It's very cool. So exponents are like the little numbers, like squared or cubed. Roots look like that. We're not going to be dealing with a ton of this just yet. We have a whole chapter on it we'll get to later. All right, now, when you see PEMDAS or my dear Aunt Sally, we think that multiplication happens before division. It doesn't. It happens from left to right. So multiplication and division are considered equals, okay? You don't have to multiply before you divide. You have to solve multiplication and division from left to right. So if division happens before multiplication, left to right, you would actually divide first. So be careful with that. Same with addition and subtraction. You're solving this from left to right. And I'm going to have you change all of your subtraction to addition anyhow, so really it's just kind of like addition is last, okay? So you're not solving all addition before subtraction, you're solving them from left to right. So in terms of, please excuse my dear Aunt Sally, the MD and the AS are kind of grouped together. There's not one before the other. All right, so let's try a few with regular numbers, and then we'll apply this whole substitution business to it. All right, evaluate each expression. Some of us get hung up on, evaluate? Well, what am I supposed to do? That just means solve it. Tell me what it equals. All right, now a lot of people, when they see this, just want to start solving it from left to right. You can't, because there's not just all addition or multiplication here. There's one of each. And according to order of operations, you have to solve all multiplication before you can add, right? So in this problem, your first step should actually be to multiply this 9 times -4. When you multiply 9 by -4, we have one of each, so I know it's a negative, and 9 times 4 is 36. I still have this -14 that I'm supposed to add to that. So I'm going to drop that down. This is what has to be done first. You can't take -14 plus 9 first and multiply the result by -4. It's not correct. You need to multiply before adding. Now, all that's left to do is add those numbers. All that's left is addition. So 36 plus 14, I know I can add them because they're the same sign. And when I'm adding same signs, I keep the sign and add the digit. So 36 plus 14, I would do 36 plus 10 first, which is 46, and 46 plus 4 is 50. So we get -50. Would it have turned out the same if you would have added those first and then multiplied? No. So -50 is what you should have. All right, take a look at this next one. The very first thing that I recommend that you do is to keep change. See this subtraction right here? So we're still going to change all of our subtraction to addition by adding the opposite. So this problem really means keep, change. Adding -2 is the same as subtracting it, right? Subtracting 2, that is. Okay, according to order of operations, the P in PEMDAS means do whatever's in parentheses first. So my first task is to solve this. I'm going to rewrite the rest of the problem because I'm not doing anything with that yet. -10 plus 15, when you have two unlike signs, we subtract the digit, so 15 minus 10 is 5, and take the sign of the greater digit, 15 is greater than 10. All right, next on our list would be exponents, and we don't have any of those. Next on our list is the MD, multiplication and division. And remember, when you have a number next to parentheses, that means multiplication, right? So you should do this first. Negative 2 times 5. 2 times 5 is 10. A positive times negative is a negative. And I still have this negative 20 being added to that. And do we have to show our work? Yes, you do. You sure do. Negative 20 plus negative 10. So same signs, add the digits, keep the sign. So the result of that's negative 30. You would not get negative 30 if you took negative 20 plus negative 2 and got negative 22 and then multiplied that by the result that's inside here. You have to solve these according to order of operations. Every time, no matter what. Always, always. Alright, next, okay, finally we've got some little exponents in here. I do see subtraction. I want you to change that before you begin. So let's change this minus 7 to keep, change, change. Because subtracting 7 and adding a negative 7 are the same thing. According to order of operations, you're supposed to solve inside parentheses first. So I'm going to bring down my negative 4. 5 plus negative 7 is negative 2. And I'm supposed to square that. So this is my new problem. Step 1, parentheses are done. Now step 2 says exponents, right? It doesn't say multiplication and division. Don't do negative 4 times negative 2. You can't do that. You have to take care of exponents first. And this exponent is attached to this negative 2. Okay? Now remember in our last lesson, we talked about when you have the quantity of a negative squared, right? So this right here, to figure out the quantity of negative 2 squared, means I'm going to take negative 2 times negative 2. That means the same thing as this, right? This 2 tells me how many negative 2's I'm multiplying. A negative 2 times negative 2 is a positive 4. So that means, to get my answer, I want to take this negative 4 and multiply it by 4. And a negative 4 multiplied by a positive 4 is a negative 16. I hope I'm not scarring anyone for life by using this red pen right now. It just seems to show up really well. I'll try to switch it up. We've been told many articles, don't use red. Sorry, it's just the pen that was here. Anyhow, if you took a negative 4 times negative 2, you'd get 8. Is 8 squared negative 16? No. 8 squared isn't 16. 8 squared is 64. But multiplying those first, you can't do it. You have to take care of the exponents first, and it's negative 2 being raised to the second power, not this negative 4. So be careful. All right, next, oh, I see some subtraction, and this time it's kind of a goofy little problem here, and this is where little mistakes can happen, so we're going to learn kind of a lot through this problem. Alright, so I showed you before how to keep change, right? And generally you just change the sign of the number that follows, but this one's a little different in terms of this subtraction sign right here. These numbers in parentheses, there's more than one number, right? So if I'm going to keep change here, so keep change, I can't just change the sign of this 6 because this is grouped all together in parentheses. So if you see subtraction sign outside of parentheses where there's more than one digit inside, it means you want to add the opposite of everything in there. Okay? So this is kind of like take the opposite of what you get when this is done. So again, if this was just negative 10 minus 6, you could change it to negative 10 plus negative 6, no problem. But because there's more than one digit inside these parentheses, now I need to add the opposite of everything in there. Those parentheses keep everything together. So just be careful with that. This one is fine. I can add the opposite, and now we're ready to move on. Okay, according to order of operations, I'm supposed to take care of whatever's inside parentheses first, right? So that means I want to take care of this 6 plus negative 8. I'm going to rewrite everything else. So I have negative 10 plus the opposite of 6 plus negative 8 is negative 2, right? Subtract the digit, sign of the greater digit, and I still have this cubed here. Okay, next in the order of operations list is exponents, right? So this quantity of negative 2 is being raised to the third power. This means, because it's inside parentheses, it was to start, that I'm taking a negative 2 multiplied by another negative 2 multiplied by another negative 2. Negative 2 times negative 2 is 4. And 4 times that last negative 2 there would be a negative 8. So the result of that is negative 8. So now what's left is negative 10 plus the opposite of negative 8, because that's what I just got. I know I told you there's lots going on in this problem. Okay, so in looking at this, if I want to take negative 10 plus the opposite of negative 8, I need to figure out what the opposite of negative 8 is, right? What's the opposite of negative 8? It's a positive 8. So this right here really means 8, because it's the opposite of. If you look at that as the opposite of, I think it's really helpful. So now this is the problem I'm left with. Negative 10 plus a positive 8, subtract your digits, take the sign of the greater, so all that work, it's negative 2. That's the solution that you should have. And we'll have more practice with those during class, I promise. All right, let's move on to the substitution portion now. Turn your page. And what is substitution? Well, you know, it's an exciting day when you walk into class and realize that Mrs. Tremblay is not here and we will have a substitute. And you all do cartwheels and you're so happy. It just makes me want to cry. I'm so glad I can't see it. Well, substitution in math, you're replacing a variable with the amount that it actually represents. So you're replacing it with something else, just like a teacher replaces, you know, a substitute teacher replaces the teacher that's in your classroom. So here we have the directions. It says try it. Evaluate each expression, so solve each expression. But wherever you see the letter P, you're going to use 3. And whenever you see U, you're going to use negative 2. And yes, PU. I did that on purpose. I can't help myself. These are, you know, it's hard to snazz it up. In math, I do my best. All right, what I recommend is you don't do any keep, change until after all the numbers are in there. So step 1, rewrite this, replacing the letters with the numbers. So this is 12 minus, we said P was 3, and U is negative 2. Now when you see that you want to substitute a negative value in, what I recommend is you always wrap it up in parentheses, because we've learned that those parentheses make a difference when there's exponents. So it's just safer to use parentheses all the time. So when I say I want U to be negative 2, that means I want it to be a negative with a 2 kept together. It's not going to be written like this for you. You have to remember to do it that way. So whenever I plug in a negative value, I wrap it up in parentheses so that I don't forget. Now at this point, you can keep, change. Once you have all those values in there, I'm going to add the opposite. Okay, order of operations applies, so we need to do multiplication before we can add. That means I need to multiply those 2 values first. No, letters next to each other means multiplication, right? This doesn't mean that I have 32. It means I have 3 multiplied by a negative 2. All right, so what is the value of PU? It's 6, because a negative multiplied by another negative is a positive, and 12 plus 6 is 18. 1 down. Keep it going. All right. I'm not going to change my signs until after I have everything plugged in. So this is 6 minus 2, and then in parentheses, P is 3, and I'm supposed to subtract U, which is negative 2. So that's what that's going to look like initially. Now that the numbers are in there, I'm going to keep, change it. So I'm going to add the opposite here, and add the opposite there. Okay, according to order of operations, our next step is to solve inside parentheses. So that means the rest of this is going to stay the same. And I'm left with 3 plus 2, which is 5. Now, according to order of operations, I'm supposed to do exponents, but we don't have any. Then, multiplication and division, we do have some multiplication. So negative 2 times 5 is negative 10. I want to take 6 plus that. 2 different signs, subtract the digits, take the sign of the greater, and it should be negative 4. Right, next. UP squared plus the quantity of UP squared. It sounds very funny to say that UP squared, but whatever, it's okay. Okay, I'm going to fill everything in first. So U is negative 2, and that's times 3 squared. So I'm going to write it like that. Plus, now this UP is in parentheses. So I'm going to open up parentheses. U I'm going to put inside another set of parentheses. I know it looks crazy. And multiply that by 3, and remember that was all together, squared. Okay, I don't see any subtraction that I need to keep, change. I do see something inside parentheses that I need to solve first though, which is this. parentheses happen first, right? So I'm going to rewrite the rest of this. Negative 2 times 3 is negative 6. That's in parentheses, right? So I'm going to put that negative 6 in parentheses. It does make a difference. Squared. The next thing on my order of operations list is the E for exponents. I see two exponential expressions I need to take care of. So I'm going to take negative 2 and multiply that by 3 squared isn't 6. It means 3 times 3, which is 9. And the quantity of negative 6 squared means I'm keeping the negative with the 6. This means negative 6 times negative 6, which is 36. All right, next on the order of operations list is multiplication and division from left to right. Here's some multiplication. A negative times a positive is a negative. And I'm left with negative 18 plus a positive 36. One of each says subtract the digits. So 36 minus 18, when you do that, you get 18. And the higher digit's positive, that means my answer is positive. Next, rolling right along here, u minus p over 5u. Don't keep change until the digits are all in there. So u is negative 2 minus p, which is 3, over 5u. That means take 5 and multiply it by u. Okay, now keep change. I'm going to change my subtraction to addition by adding the opposite. When you see a fractional expression like this set up, you kind of separate the two. So you're going to take care of the top, take care of the bottom, and then you would divide. So kind of look at this as two separate problems. So the first thing I want to do is look at this as one separate thing. Negative 2 plus negative 3. All right, well, I'm adding the same sign. Keep the sign, add the digits. Then we want to take care of the bottom. 5 multiplied by negative 2, that's a negative 10. Now let's simplify. I know that this is division, right? And when you divide a negative and a negative, you get a positive. So I should have a positive result. A lot of people want to tell me this is 2. And 10 divided by 5 is 2. But 5 divided by 10 isn't. 5/10 is equivalent to 1/2. So your final answer should be 1/2. Or if you wrote 0.5, that means the same thing. So does 0.5, whatever floats your boat. Just don't write 2, because 5 divided by 10 isn't 2. 10 divided by 5 is. All right. Next one, u squared minus u squared. Now, some of you, I'm hoping that when you look at this, you think, well, any number minus itself is 0, so I know that that answer is 0 without doing anything. That's awesome. If you didn't take that route, and you didn't see that connection right off the bat, you're probably like, oh, man. But let's work through it and make sure we got 0. So if u is supposed to be negative 2, that means it's in parentheses. It's in parentheses. Okay. When you keep change this one. This is where it gets kind of tricky. I know we said that if there's something going on inside here, that you can't, if there's more than one digit inside here, that you can't just add the opposite. If I were you, before you keep change this because you see the exponents, you're going to get the same answer either way. But I would just take care of these expressions first. If you did it the other way and you added a positive, you're still going to get the same answer. So the quantity of negative 2 squared, negative 2 times negative 2 is 4. And the quantity of negative 2 squared is 4. And 4 minus 4 is 0. If you would have done this, then you would have had 2 squared, which is 4, right? 2 squared, which is 4. Then I have plus 4, 4 plus 4. That's not going to work, right? So I know you'd get the same result here, but it messes up that. So when you see an exponent there, you're not allowed to keep change inside those parentheses because this needs to be taken care of first. So you can't do that. Don't change subtraction until after the fact or you'll get the incorrect answer. I know, lots of little tiny things. Isn't it crazy? That's why we do all kinds of practice in class. All right, last one, 2 times the quantity of 6 minus u over u cubed. Okay, so I'm going to plug it all in. I'm putting that negative 2 in parentheses, so we have parentheses, parentheses. And then I have u cubed, which means the quantity of negative 2 cubed. All right, again, look at these as two separate problems. Let's take care of the top first. On the top, I'm supposed to keep change. There's not an exponent attached to this, right? So I'm just going to add the opposite. I'm supposed to solve in those parentheses. So 6 plus 2 is 8, so I'm left with 2 times 8. And 2 times 8 is 16, right? Now I have the quantity of negative 2 cubed. Remember, that means that I'm multiplying 3 negative 2's. I think we've done this one enough. Negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So we're left here with 16 divided by negative 8, and 16 divided by negative 8 is a negative 2. We're finally done. I'll see you tomorrow.